This presentation will review the Georgia Standards of Excellence 5 MBT5, which states that students will fluently multiply multi-digit whole numbers using the standard algorithm or other strategies demonstrating understanding of multiplication up to a 3-digit by 2-digit factor. The standards focus on required fluencies for each grade level. Third grade students focus on learning their multiplication and division facts within 100 with an expectation that they know the products of two one-digit numbers by the end of the year. Fluency with multi-digit multiplication is worked on throughout 4th and 5th grades with an expectation of fluency by the end of 5th grade. As we dive into the standard, it is important to address what fluency means. The National Council of Teachers of Mathematics describes procedural fluency as the ability to apply procedures accurately, efficiently, and flexibly, to transfer procedures to different problems and context, to build or modify procedures from other procedures, and to recognize when one strategy or procedure is more appropriate to apply than another. The emphasis is not on time, test, or speed, or one specific strategy over another. Students progressing from 4th grade have experienced multiplying a whole number of up to 4 digits by a 1-digit whole number, as well as two 2-digit numbers, with the emphasis being on using strategies based on place value and the properties of operations, and by using equations, rectangular arrays, and/or area models. To learn more about multiplication in 4th grade, please visit the link below this presentation to view the Georgia Standards of Excellence instructional video on 4 MBT5. For additional information, you can also check out Graham Fletcher's video on the progression of multiplication. The video details the connections that students make as their understanding naturally progresses through the end of 5th grade. As students enter 5th grade, it is important to scaffold instruction and use the CRA approach to model how strategies and algorithms are connected. In the upcoming video, you will see how one student uses base 10 blocks to find the product of 11 times 15. What is the product of 11 times 15?
11 times.
Let's add up all of the partial products. What would the total product be?
100, 110, 120, 130, 40, 150, 165.
165. Regardless of the strategy or algorithm used, the most important component is if the strategy used is efficient and makes sense. As stated in the Georgia Standards of Excellence Math Glossary, a standard algorithm is an algorithm based on place value decomposition. The standard algorithm is not exclusive to the U.S. traditional algorithm. Students need to make sense of their learning in context without specific procedures forcing specific steps. 5th grade students begin to work on multiplication of up to 3-digit by 2-digit numbers. Students can use the properties of operations as they multiply the value of the digits in each factor by the other. For example, 80 can be thought of as 8 times 10. When multiplying 80 times 700, we can think of making 700 10 times bigger, and then multiplying by 8 to get the partial product of 56,000. 60 becomes 10 times bigger, and multiplied by 8 to become 4,800. And students expand on their understanding from 3rd grade when multiplying a single-digit factor by a multiple of 10. When multiplying 8 times 50, the product is 400. After calculating the partial products, students then add them together to find the total product. The area model helps students transition to the partial products algorithm that continues to focus on the place value of each digit. Students first multiply the digit in the ones place by the value of the digits in the other factor. They then repeat these steps by multiplying the value of the digit in the tens place. The partial products are added together to find the total product. A common misconception of teaching multiplication in 5th grade is thinking that students must use the U.S. traditional algorithm to master the standard. The goal of being a fluent mathematician is not about memorizing steps or procedures. It is about understanding why a specific strategy or algorithm works. As Joe Bowler states, When students are trained to memorize math facts blindly and work with algorithms before they understand them, they automatically resort to memorization and never develop the ability to think of numbers flexibly. Fluency involves efficiency and flexibility. In this example, there are 25 dozen cookies in the bakery. What is the total number of cookies at the bakery? Student A broke the 12 up into 10 and 2. 25 times 10 equals 250, and 2 more groups of 25 equals 50. While student B decided to decompose the 25 into 5 groups of 5. 5 times 12 equals 60. Then 60 times 5 equals 300. Student C then used the doubling and halving strategy to create friendly numbers. 25 doubled is 50, and half of 12 is 6. 50 times 6 also equals 300. In this next example, compensation or friendly numbers are used to solve 247 times 19. We can easily solve 247 times 20 by multiplying 247 by 10 2 times. These partial products can then be added together. The final product is reached by subtracting the extra group of 247. In the upcoming videos, check out how students use compensation to solve multiplication problems. So how can 400 times 20 help you solve 399 times 20?
So if 400 times 20 is 8,000, then that means I just need one less group of 20. So therefore, the answer is 7,980.
Since 400 times 20 equals 8,000 and 421 is just one more group of 400, you could just do 8,000 plus 400, which equals 8,400.
As students in your classroom use different strategies to solve the same problem, it is critical for students to see these different strategies side by side so they can look for connections between algorithms. For instance, ask students, where is the 474 in the representation on the left? It is the sum of the first 3 partial products. And where is 3,160? Students should see it as the sum of the last 3 partial products. The U.S. traditional algorithm uses the same basic computations, but with a shorthand approach to representing place value. This particular written method may not make sense to some students and does not have to be used in order to master the standard. While it may be tempting to teach tricks to help students memorize the steps to take, tricks like the turtle head method and butterfly method take away from the place value understanding and cause later confusion when the trick no longer works with larger numbers. To encourage students to apply their understanding of multiplication, it is important to incorporate a variety of games and real-world tasks. In the upcoming video, students use digit cards to create a 3 times 2-digit multiplication problem with the goal of having the greatest product. While one student decided to use the U.S. traditional algorithm, the other student used the area model and then added up the partial products to find the total product. In this next task, students worked with partners to solve a series of multiplication problems through a real-world context. The pool needs to keep a constant heat of 83 degrees and wants to determine which company provides the best deal. Students had to analyze the prices per month from 3 different companies before finding the best deal. Instead of a printed worksheet with rows of problems to complete, this rich task encouraged discussion and application. Which company has the best deal?
Their current company,
And how do you know?
because I multiplied the number of money and by the number of months bought for all of these, and I added them together, and this was the cheapest out of these 3 companies.
Although there was only one required final answer, the task encouraged students to address multiple standards of mathematical practice. Students reasoned abstractly and quantitatively, constructed viable arguments, and critiqued the reasoning of others, as well as attended to precision. In this next task, Sean's dog tore up his homework. He found the 6 and 0 and remembered where they went, and then found the digits 2, 5, 4, and 3, and remembered that they belonged in the boxes, but he wasn't sure which number went where. This task proved quite rigorous as students explored different possible combinations.
I knew that 2 times 5 would be 10, and there needed to be a 0 there, for if it was going to be added, there would be a 0 there. But then this strategy doesn't work because it would make 10 and there would be 1 up there, so that would make that 7 instead of 6.
So what have you gotten so far?
So far, I have these three numbers to equal 160 on the top, but this one
So we
really
have
hard.
2 times 5 is 10.
is 10, plus 5 times 30 is 150, which equals 160.
Okay, so you had an extra group to add to that. Okay.
Yep.
So what would go there? What's left?
I can't figure it
Or
out.
which one of these?
I
Yeah.
think, oh yeah,
Yeah,
it's 4.
there's only one left. Okay, now finish solving the problem.
Okay.
As the video showed, the missing digits allowed students to use a variety of problem-solving skills as they justified their thinking and reasoning. Any problem, regardless of the algorithm used, can be turned into an engaging opportunity to apply understanding. For example, encourage students to find the factors when given the partial products, or find the missing digits when using the U.S. traditional algorithm. For additional support and resources, please visit Unit 1 in the 5th grade standards at GeorgiaStandards.Org.